Good morning everyone. I am Aaron Monton. Today, I will be discussing about ultrasonic sensor. Ultrasonic sensors are widely used around the world. It may be indoors or outdoors, and in the harshest conditions for a variety of purposes and applications. Ultrasonic sensing is one of the best ways to sense proximity and detect levels of high reliability. So, what is an ultrasonic sensor? As the name indicates, ultrasonic sensor measures the distance by using ultrasonic waves. As we can inspect with the figure, the sensor head emits an ultrasonic wave and receives the wave reflected back from the target. Ultrasonic sensor measures the distance to the target by measuring the time between the emission and reception. This uses transducers to send and receive ultrasonic pulses that relay back information about the object's proximity. In calculating the distance, this is very relative to the past lessons we had on physics. This utilizes the formula that distance is always equal to the product of the speed and time. So, here's a sensor diagram. Here, we could see 4 pins, namely the red one, the VCC pin, the orange one is the trigger pin, the purple one is the echo pin, and the black one is the ground. Now, for the VCC pin, its function is to power up the sensor. This is typically and approximately 5 volts in nature. However, the trigger pin is the input pin. This pin has to be working for 10 microseconds to initialize measurement. On the other hand, the echo pin serves as the output pin. This pin will increase and will always be equal to the time taken for the wave to return back to the sensor. The ground pin is obviously connected to the ground of the system. Now, let's do a recap. For the VCC pin powers up the sensor and typically has 5 volts. For the trigger pin, this is an input pin. This pin has to be kept for 10 microseconds to initialize measurement by sending waves. Now, for the echo pin, this pin goes high for a period of time which will always be equal to the time taken for the wave to return back to the sensor. Now, the ground pin is always connected to the ground of the system. So, how does an ultrasonic sensor work? First of all, we should understand that ultrasonic waves vibrates at a frequency above the range of a human hearing. Now, the module has 2 eyes that project in the front, which forms the ultrasonic transmitter and the receiver. The sensor works with a simple high school formula that the distance is always equal to the product of the speed and time. The ultrasonic transmitter transmits an ultrasonic wave. This wave travels in air, and when it gets back to the object, by any material it gets reflected back towards the sensor. This reflected wave is observed by the ultrasonic receiver module as seen in the figure. Our sensor utilizes a single transducer to send a pulse and to receive the echo. The sensor determines the distance to a target by measuring time lapses between the sending and receiving of the ultrasonic pulses. So, let me enlighten this.
Hello, Dan Nedelkowski here from howtomechatronics.com. In this tutorial, you will learn how to use the HC SR04 ultrasonic sensor. It can measure distance from 2 centimeters to 4 meters with a ranging accuracy up to 3 millimeters. The working principle of this module is quite simple. It emits an ultrasound at 40,000 Hz, which travels through the air, and if there is an object or obstacle on its path, it will bounce back to the module. Considering the travel time and the speed of the sound, you can calculate the distance. The module has 4 pins, ground, VCC, trig and echo. The ground and the VCC pins of the module needs to be connected to the ground and the 5 volts pin on the Arduino board respectively, and the trig and echo pins to any digital input-output pin on the Arduino board. In order to generate the ultrasound, you need to set the trick on a high state for 10 seconds. That will send out an 8-cycle sonic burst, which will travel at the speed of sound, and it will be received in the echo pin. The echo pin will output the time in microseconds the sound wave traveled. So, for example, if the object is 10 centimeters away from the sensor and the speed of sound is 340 meters per second or 0.034 centimeters per microsecond, the sound wave will need to travel about 294 microseconds. But what you will get from the echo pin will be double that number because the sound wave needs to travel forward and bounce backward. So in order to get the distance in centimeters, we need to multiply the received travel time value from the echo pin by 0.034 and divide it by 2.
So now that it was enlightened, why should we use an ultrasonic sensor instead of other sensor? Now, ultrasound is very reliable in any lighting environment and can be used inside or outside. Ultrasonic sensors can handle collisions avoidance for a robot and being moved often as long as it isn't too fast. Ultrasonics are so widely used they can be reliably implemented in green bin sensing applications, water level sensing, drone applications, and sensing cars at your local drive-thru restaurant or bank. So, here are some of the three use of an ultrasonic sensor. Number 1, ultrasonic sensors are best used in the non-contact detection of presence, level, position, and distance. Number 2, ultrasonics are independent of light, smoke, dust, color, and material. Long-range detection of targets with varied surface properties. So, here are the advantages of ultrasonic sensor. Of course, number 1, they can be used in dark environments. Number 2, they have greater accuracy than many other sensors in measuring thickness and distance to a parallel surface. They are high frequency, sensitivity, and penetrating power makes it easy to detect external or deep objects. And the last one, our sensor easily interfaces with microcontrollers or any type of controller. Limitations of ultrasonic sensors. Number 1, cannot work in a vacuum. Number 2, of course, not designed for underwater use. Number 3, sensing accuracy affected by soft materials. Number 4, sensing accuracy affected by changes in temperature between 5 to 10 degrees or more. Of course, for the last one, they have a limited detection range.